Hi everybody. We have absolute value inequalities that we're going to work on solving. They are tied pretty closely to compound inequalities, which we've been spending a couple days on. What I'd like to look at first are just a couple of examples here, and just where do the numbers that satisfy this fall. The absolute value of x is less than 4. So if I were to put negative 6 and have the absolute value of negative 6, that would be 6. And 6 is not less than 4. And I think you'd find the same with negative 5, with negative 4. With negative 4, it actually equals. So I'm going to put an open circle here. Negative 3. The absolute value of negative 3 is 3. 3 is less than 4. So that's a solution. I think negative 2 you'll find is a solution. Absolute value of negative 1 is 1, and 1 is less than 4. Absolute value of 0 is less than 4. 1, absolute value of 1 is 1. 2, 3, and then 4 again. So, and if I go to 5, absolute value of 5 is 5. 5 is not less than 4, so I wouldn't do that. So I'm going to, as I think about this, I'm going to shade and just go between negative 4 and positive 4 with open circles, because it's not or equal to, it's just less than. It's not less than or equal to, it's less than. If it were less than or equal to, I'd color those in, but that's not the case here. And I do want you to look at this. This is less than. And look at what the graph is doing here. And let's, in contrast, let's look what greater than. And I just have absolute value of x is greater than 3. Now, if I put negative 6, absolute value of negative 6 here is 6. And 6 is greater than 3. So, yeah, that would count there. 5. Absolute value of negative 5 is 5 is greater than 3. Negative 4 is greater than 3. This one's equal. Negative 2, I wouldn't put that down as a solution. Negative 1, absolute value of 1 is negative 1 is absolute value of negative 1, is 1 is not greater than 3. 0 is not greater than 3. 1 is not greater than 3. 2, but I think after we stop here, 4 is greater than 3. 5, 6. Okay. So I'm seeing this one going like this. And in the lesson we just did, this looks like the solutions when we had the and composite or and compound inequalities. This to me looks like what we had when we had the or. Less than goes with and, greater than goes with or. And I've got a corny way of remembering that. If I see less than, absolute value is less than, sometimes I'll just say less than. And if I see greater, absolute value is greater, sometimes I'll just think greater. Okay, so the ors and the ands. So when we set these up, that's going to be important. And I've got just a general statement here of what are you going to do when you have this. Now this is greater. So what I would want you to do every time you get this, I would want you to set up ax plus b is greater than c, okay, or ax plus b is less than negative c. Okay, so the first time you go greater, then you switch it to less than. Okay, on this one, on the other hand, I'll write ax, let me put both those there, ax plus b is less than c, and ax plus b is greater than negative c. So do you notice I have the greater than, that I have the sign that it was and the c, and then I have the sign switched and the opposite, the negative c. And here I have the sign that it was, less than c, and then I switched this and made negative c. Guess got to know less than and great. Oh, this is greater and less than. Okay. Now also with less than, I'm going to do this usually when I set it up. It'll just make it a little easier to do. Okay, so that's just some general information. Now I have a couple of examples. I'm going to solve this and put the graph, the solution, on a number line. And absolute value of 4x plus 7 is greater than 13. Now this is greater. So I'm going to write 4x minus 7. Notice I take the absolute value bars off now. Is greater than 13. Or 4x minus 7 is less than negative 13. Alright, now you just solve each. These are things you were doing on your worksheet. So let's solve each. Let's add 7. Let's add 7. I got 4x is greater than 20. I divide by 4, and I get x is greater than 5. And I add 7. I do also want you to notice that I'm not changing this sign in either one of them. That stays. What's in the absolute value stays. What changes is what's outside, what's on the other side of the inequality. So I have 4x is less than negative 6, and I divide by 4. So, or x is less than negative 1.5. X is greater than 5, this way, or x is less than negative 1.5. I'm going to put an open circle right between those two and go this direction. Okay, and that's an open circle there. So there's my solution. Here's my inequality description. Here's my description of the solution on a number line. And one more example here. 5x plus 2 is less than or equal to. This is an and. Less than is an and. I like to set up the 5z plus 2 and go 17 here, and then just do it together like this for and. I don't do that for or, I just do that for and. And let's subtract 2 from the middle, subtract 2 from the right, and subtract 2 from the left. That's negative 19 here. That cancels, so that is 5z here. And 17 minus 2 is 15 here. So I'll divide by 5 in the middle, on the right, and on the left. This is z, or equal to. If you didn't get that, that's my fault. Don't forget to put that or equal to part there. And 15 divided by 5 is 3. 19 divided by 5. 5 times 4 is 20. So it's, I think, negative 3.8. Okay. Now, greater than or equal to negative 3.8. So I'm going to put a solid circle here. I might just write negative 3.8 above it. And then a solid circle for 3 here. Everybody understanding why? And then I will make that segment. I'll shade between them. Okay, guys, you have fun with this and take care.